Maths and Methods Academy. In this video we are going to resolve given algebraic fractions into partial fractions. So let's go on with our solution. Our first question in this case is x cubed over x squared plus 4 whole squared. Here we are going to check, like always, for the first time, like always. Initially we have to check if the denominator is having high degree of x or the numerator has to have lower degree of x. Only then we can go ahead and start forming the partial fractions. So the degree of x in numerator is 3 here, and degree of x in denominator is x4. x4 in the sense, when we will open the square, the x squared raised to power 2 will be equal to x4, which means it is greater than the denominator. So we can go ahead and form the partial fractions. But before that we have to check one more thing, the type of the factor. This factor is actually repeated quadratic factor. And whenever we have a quadratic factor, we are introducing two variables in the numerator. First one with x and the second one without x. Over we will write x squared plus 4, and since it is a repeated quadratic factor, we have to write one more factor which will be on the same pattern, like cx plus d over x squared plus 4 whole squared. So this is how we will form the the partial fractions. And now we will multiply both sides by x squared plus 4 whole square. That's it. So this expression will cancel with this one, and we are left with x cube is equal to, we'll multiply x square plus 4 whole square with both the terms inside the bracket. So we'll be getting ax plus b into x squared plus 4 plus cx plus d. Now, since we don't have any linear factor in the denominator in this algebraic fraction, so we cannot assume values of x in this equation number 1 and find out the values of the constants a, b and c. So for this purpose we have to solve this equation and compare the coefficients of different degrees of x on both sides. So left side we can write like x cube plus 0x squared plus 0, because we don't have any x square value, so we are putting 0 with it, and we don't have any constant, so we are putting a 0 in place of that. So let's solve this equation. We will multiply ax with x squared, ax with 4, it will be 4ax plus bx squared plus 4b plus cx plus d. Now we will combine the x value of the same terms. We have only one value of x cube, then we have only one value of x square, then we can write 4ax, and we have another value with a term with x, which is cx, plus 4b plus d. So we can write like ax cubed plus bx squared plus 4a plus c into x plus 4b plus d. Okay. Actually we have to write one more value here, which is 0x plus 0. So we are writing here x cubed. We can write it 1x cubed, 0x squared plus 0x plus 0 is equal to ax cubed plus bx squared plus 4a plus c into x plus 4b plus d. Let us compare the coefficients of x cube first. This is the a is the coefficient of x cube on the right side, and 1 is the coefficient of x cube on the left side. So when we compare it, we get a is equal to 1. After that, we will compare the coefficients of x squared. Here we can see that b is equal to 0. Now we will compare the coefficient of x and the term which is without x. So with x1 is this one. So 4a plus c is equal to 0. We have the value of a, which is 1. 4 plus c is equal to 0. Therefore c is equal to minus 4. C is equal to minus 4. Now we will compare on the both sides the terms which are without x. So 4b plus d is equal to 0. We have the value of b as 0. So 0 plus c is equal to 0. Sorry, it is d, not c. D. So our value of d is equal to 0. Now we have all the 4 values of the constants a, b, c and d. So we can write our partial fractions. So x cubed over x squared plus 4 squared is equal to a is 1 into x, b is 0 over x squared plus 4 plus c is 0, so 0x, and d is 1x plus c is minus 4. Here c is minus 4. This is the one. Minus 4 into x plus 0 over x squared plus 4 squared. Now we will simplify it. 1 into x is x plus 0 is same x. So x over x squared plus 4 minus 4x plus 0 is minus 4x. Minus we will take out, so we will write 4x over x squared plus 4 whole squared. And this is the answer of our first question of this video. Now we'll go ahead with our second question. The second question is x4 plus 3 into x raised to power 2 plus x plus 1 over x plus 1 into x squared plus 1 whole squared. So the degree of our, in this question, the degree of x in numerator is 4 and in the denominator it is 5. How it is 5? Where we will take square of x square, which will be x4, and multiply it with this x, it will come out to be x5, which is greater than the numerator. So we can straight away inform partial fractions here. Our first degree is, first factor is linear factor. Our second factor is repeated quadratic factor. So we'll be having two partial fractions for this because its power is 2. If its power is 3, then we'll be having 3. It depends upon the power that is showing outside the bracket, which is this one, 2. Okay, so first of all we'll write for the linear factor. It will be very simple, a over x plus 1. Then we will write for the quadratic factor, which will be bx plus c over x squared plus 1, and then for the repetition it will be dx plus e over x squared plus 1 whole squared. Now we will multiply both sides by x plus 1 into x squared plus 1 whole square. So how it will be done? X plus 1 into x squared plus 1 into x4 plus 3x squared plus x plus 1 over x plus 1 into x squared plus 1 whole squared. So x plus 1 into x squared plus 1 whole squared. We will multiply it with all the three terms, a over x plus 1 plus bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 whole square, and bracket close. This will cancel with this one, and we will write x4. We don't have x cube here, so we will write 0x cube. We don't have any term with x cube, that's why we will write 0x cube plus 3x squared plus x plus 1. Now we will multiply x plus 1 into x squared plus 1 whole square with all the three terms inside the bracket. So we will be writing a into x squared plus 1 whole squared plus bx plus c into x plus 1 x squared plus 1, and the third one is dx plus e into x plus 1. Now in this case, this is actually equation number 1. Here we can find out at least one value by assuming a value of x equal to -1. So let's do that. Let x is equal to -1. The equation will look like -1 raised to power 4 plus 0 into -1 raised to power 3 plus 3 into minus 1 raised to power 2 plus minus 1 plus 1 equals to a into minus 1 squared plus 1 whole squared plus b into minus 1 plus c into minus 1 plus 1 into square of minus 1 plus 1 plus d into minus 1 plus e and minus 1 plus 1. So what will happen here? Minus 1 raised to power 4 will be 1. Anything multiplied by 0 will be 0. Minus 1 square is 1 into 3 plus 3. Then minus 1 into plus, it is minus 1. Then plus 1 is equal to a into 1 plus 1 whole squared. And the remaining two values are 0 because of this and because of this. 0 plus 0. This cancels with this. 3 plus 1 is 4. It is equal to a into square of 2. 4 is equal to 4a. So we divide both sides by 4. So a is equal to 1. Now we have no other value that we can assume in the equation to find the remaining constants. Remaining constants are b, c, d and e. So let's go ahead and solve this equation. Let's write down the equation one more time. x4 plus 0x cube plus 3x squared plus x plus 1 is equal to a into x squared plus 1 whole square plus bx plus c into x plus 1 into x squared plus 1 plus dx plus e into x plus 1. Let's simplify it. We'll open the square first. X raised to power 4 plus 2x square plus 1 plus bx plus c. First we will multiply these two, so we will be getting x cubed plus x squared plus x plus 1 plus dx squared plus dx plus ex plus e. Okay, now we will have ax4 when we multiply a with all the terms inside, so we will be having 2ax squared plus a. Now we will multiply bx with all these terms one by one, so it will be b x4 plus bx cube plus bx squared plus bx. Then we multiply c with all this. It will be cx cube plus cx squared plus cx plus c. Then comes the last one. Dx squared plus dx plus ex plus e. We have to write it as it is, plus dx squared plus dx plus ex plus e. Now we will gather the terms with the similar degree of x. So first we will write ax4 plus bx4. Then we will look for the cube if there is any. Yes, we have bx cube and we have cx cubed. Then we have x squared values, which are 2a x squared plus bx squared plus cx squared and plus dx squared. And now we will write the terms with only x's. So there we have, first one is bx. After bx we have cx, then we have dx, and then we have ex. And in the end we will write all those terms which are having no x. So that is a, this one, a plus c, this one, and then this e. Okay, let's take common now. In the first two terms, x4 is common, and in the second, third and fourth, x cube is common, and for x squared we have 4 values. X squared, yeah, it is 2a plus b plus c plus d, and then outside common x, plus now the 4 terms bx, cx, dx and ex, we will take common x, b plus c plus d plus e, outside it is x, and then we will write the term which is, the expression which is without any value of x. Okay, we have already found a is equal to 1. Okay, let's compare the coefficient of x4 first. Since x4 is not having any coefficient, so it will be 1. So when we compare both, a plus b is equal to 1. We have already found out a, which is 1. So b is equal to 1 minus 1, which means b is equal to 0. Then we will compare the coefficients of b plus c. This is b plus c and this is 0. So coefficients of both x cubes. So we have b plus c is equal to 0. What did we find out? b is 0. So 0 plus c is equal to 0. which means C is also equal to 0. Now we will compare the coefficients of the terms which are without x. So let's do that. It is this one. So a plus c plus e is equal to 1. The value of a is 1. The value of c is 0. So 1 plus e is equal to 1. So e is equal to 1 minus 1, which means e is equal to 0. Now we need to find the last one, which is d, the last constant. For that we will compare the value of the coefficients of x. Since this x is not having any coefficient, so it will be 1. So let's compare it with this. By comparing, we are getting b plus c plus d plus e is equal to 1. B and c are 0 and e is 1. So e is also 0, is equal to 1, which means d is equal to 1. So since we have all the constants value with us now from a to e, we can write the partial fractions. x4 plus 3x squared plus x plus 1 over x plus 1 into x squared plus 1 whole squared is equal to 1 over x plus 1 plus 0x plus 0 over x squared plus 1 plus 1 into x plus 0 over x squared plus 1 whole squared. So 1 over x plus 1 plus 0 over x squared plus 1 plus x plus 0 over, since 0 divided by any number or any expression is 0, so we will not write it now, we will be writing the rest. 1 over x plus 1 plus x plus 0 is x over x squared plus 1 whole squared, and this is the answer of our question. And now we are going for the last one. The last question is x squared over x plus 1 into x squared plus 1. It is quite obvious that it is a proper algebraic fraction, so we can go ahead straight away and write and form its partial fractions. Let us identify the factors first. This is linear factor, and this one is repeated quadratic factor. Why we call it quadratic? Because the maximum power of x in this expression is 2. And why we call it repeated? Because the whole expression has power also, which is 2 outside the bracket, this one. So it shows that we'll be having two partial fractions for this, and number of partial fractions depend upon the power which is there outside the bracket. If it is 3, we will have 3 factors. If it is 2, then we will be having two partial fractions for this one. So let us write the first one first. For linear one, we simply write a over x plus 1. The next one we will be writing with two constants, one of them with the x and one without x, over x squared plus 1. And the third one will be dx plus e over x squared plus 1 whole squared. Now we will multiply both sides by x plus 1 into x squared plus 1 whole squared. X plus 1 into x squared plus 1 whole squared. X squared over x plus 1 into x squared plus 1 whole squared is equal to x plus 1 into x squared plus 1 whole square into a over x plus 1 plus bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 whole squared and bracket close. This will cancel with this and we are left with x squared is equal to x plus 1. Okay, now what we will do, we will multiply x plus 1 into x squared plus 1 whole square with all the three terms inside the bracket. So when we multiply, the first one will come a into x squared plus 1 whole squared. The second one will be bx plus c into x plus 1 into x squared plus 1. Then the third one dx plus e into x plus 1. Let's simplify. Here at least we can find the value of one constant by assuming the value of x equal to minus 1. So let us assume it. Let x is equal to minus 1, then the equation becomes minus 1 squared is equal to a into square of minus 1 b into minus 1 plus c to minus 1 plus 1 square of minus 1 plus 1 plus d into minus 1 plus e minus 1 plus 1. Okay, let's simplify it. Square of minus 1 is 1. So a into square of minus 1 again 1 plus 1 whole square plus, because of this whole term will be 0 and because of this whole term will be 0. So 1 is equal to a into 2 squared. So 1 is equal to 4a, which means, and we divide both sides by 4. Therefore a is equal to 1 over 4. Now we don't have any value of x that we can assume to find the value of any other constant. So what we will do, we will solve the equation number 1 now. Let's go ahead with this. X squared is equal to a into, we will open the bracket, the square x4 plus 2x squared plus 1. We will multiply both the brackets, this one and this one. It will be x cube plus x squared plus x plus 1 plus, now we will multiply dx plus e with x plus 1, so we will be getting dx squared plus dx plus ex plus e. Now we are getting a x4 plus 2x squared plus a 2ax squared, 2ax squared plus a, here bx4 plus bx3 plus bx2 plus bx, then cx cube plus cx squared plus cx plus c plus dx squared plus dx plus ex plus e. Now we will combine the values of x which are with the same degree. So we have ax4 and bx4. These two are with the degree of x4. Now we will look for the third degree, which is bx cube. Then we have cx cube. Now we look for the square, which we have 2ax squared plus bx squared plus cx squared plus dx squared. And now we look for the terms which are with x variable, so it is bx plus cx plus dx plus ex, and in the end we are left with a plus c plus e, which are without any x. Now we will take the, first of all let us write the left side as 0x4 plus 0x cube plus 1x squared plus 0x plus 0 is equal to we will take x4 common, so we will have in the bracket a plus b. Then we will take x cube common, b plus c into x cubed, and now we will take x squared common, so we will have 2a plus b plus c plus d, and outside x squared is there, plus now we will take x common, so we are having b plus c plus d plus e into x plus the last term without x, a plus c plus e. Now we have already found the value of a, which is 1 over 4. Now we will compare the coefficients of x4, this one with this one, to form an equation. So a plus b is equal to 0. The value of a we have already found, which is 1 over 4, plus b is equal to 0. Therefore b is equal to minus 1 over 4. Now we will compare the coefficients of x cube, which is this one, b plus c is equal to 0. We have found the value of b, which is minus 1 over 4, plus c is equal to 0. Therefore c will come out to be 1 over 4. Now we will compare the coefficients of the terms which are without x. So A plus C plus E is equal to 0. A is equal to 1 over 4. C is also 1 over 4. So we have 2 over 4 plus E is equal to 0. This cancels and it becomes 1 over 2, which means E will be equal to minus 1 over 2. Now we will compare the coefficients of x, which is this one. So B plus C plus D plus E is equal to 0. The value of B is 1 over 4. Minus 1 over 4. C is 1 over 4. D minus 1 over 2 is equal to 0. This will cancel with this one. So D minus 1 over 2 is equal to 0, which means D is equal to 1 over 2. Now we have figured out all the 5 constants from A to E. So we are in a position to write the partial fractions now. So our algebraic fraction is x squared over x plus 1 into x squared plus 1 squared is equal to 1 over 4 over x plus 1 minus 1 over 4x plus 1 over 4 over x squared plus 1 plus 1 over 2x minus 1 over 2 over x squared plus 1 whole squared. Let's further simplify it. 1 over 4 into x plus 1. Here we will take minus common, so we will be left with x minus 1 over x squared plus 1. Then here we will take LCM, so it will become x minus 1 over 2 over x squared plus 1 squared, 1 over 4 into x plus 1 minus x minus 1 over 4 into x squared plus 1 plus x minus 1 over 2 into x squared plus 1 whole squared. And this is the answer of our final question of this video. And that's all for now. Please don't forget to subscribe the channel, and until the next time, take care and bye.